Hi, everybody. So we're going to go through some of the problems. This is section 1.1. Um, so I'm gonna be focusing really on the even problems. I want to get even. I see what I did there. I said get even, but I mean to say is that the odd problems I usually solve for homework and stuff. I'm going to go with some of the easy problems now, the even problems now. So let's look at 2, 4, and 6. Are which determine whether this equation is linear in variables x and y. So I'm just going to do 2, 4, and 6. So number two is 3x minus 4xy equals 0. Well, because you have x times y, that makes it nonlinear. That makes it a nonlinear equation. And for number 4, because you have x to the second power and you also have y to the second power, either one of these makes it non-linear. Linear has to be like, well, like, ax plus by equals c. A, B, and C are constants. Now, let's look at number 6. Number 6, sine 2x minus y equals 14. So right away, you might have a reaction. Hey, sine is a nonlinear function, but this doesn't matter because this is not sine x, it's sine 2. Sine 2 is just a constant. So it's just a constant times x, and a constant times y equals some other constant. And that therefore 6 is linear. So we have 2 is nonlinear, 4 is nonlinear, and 6 is linear. Now let's see what other torture we have here. Parametric, okay. And I mentioned that parametric is extraordinarily important. So let's look at the even problems, 8 and problem number 8 and problem number 9. So I'm going to just write these down first of all. 3x minus 1 half y equals 9. Okay, this is number 8. So I'm going to switch now. I'm going to switch. I'm going to stop the share. Okay, you should be able to see my paper now. 3x minus 1 half y equals 9. So I'm going to do, basically, I'm going to solve for y. We're going to isolate y. Let's just do it this way. Let's see. 1 half y equals 3x minus 9. And then I get y is equal to 6x minus 18. So the way I'm going to do this now is that my solution is going to be x is going to equal t, and y is going to be 6t minus 18. And this is really my solution set. This is my solution set right there. And the beauty of parametrics, or one of the beauties of parametrics, as I mentioned in the video, we know that this equation, let's look at my original equation. My original equation, we know has infinite solutions. But just because it's infinite doesn't mean it's random. Like I can't let x equal 100 and y equal 5. That will not come out to equal 9. You see what I'm saying? Yes, there are infinite solutions, infinite pairs of x and y, but not every pair of x and y is going to be a solution. Well, so I can't just randomly pick an x and a y. But what's beautiful here is that I can randomly pick any t that I choose. Let's pick, I don't know, t equals 17. Why am I doing this? Okay, t equals 17. So if t equals 17, then, well, x is just going to be 17. And y is going to be, let's see, 6 times 17 is 102. 102 divided by minus 18 is 84. Well, let's see if this actually works. 3 times 17 minus 1 half times 84. What is that? That's 51 minus 42. That indeed equals 9. So does this equal 9? Check. It equals 9. And it works because that's what it's supposed to be. It's supposed to be 9. So this is beautiful. This was number 8 on 1.1, right here, 1.1. Okay, let's go to number 10. in 1.1. Let's go to number 10 in 1.1. So number 10, we're going to, first we're going to all right. I'm just gonna copy it. I'm copying it now. So 1.1, number 10, 1.1, number 10. So we have here 13 x1 minus 26 x2 plus 39 x3 equals 13. Well, to be honest with you, the first thing I'm going to do here is to make my life easier, and that's really what I care about, is making my life easier. I'm going to divide everything by 13. I'm going to multiply everything here by 1/13. And now I get x1 minus 2x2 plus 3x3 equals 1. Now remember, x1, x2, x3, that's another way. These are variables. The x's are variables. That's one thing. When you take like a high school algebra class, usually x is a variable and x1 is a constant. Like you know, like you have like in the slope, right? So not this the point slope formula. Y minus y1, y minus y1 equals m times x minus x1. So usually when you have the x1 subscript, it means a constant. But in our course, this is going to be a variable. So instead of saying x, y, z, you say x1, x2, x3, and the reason for that is because if I say x, y, z, what comes next? What if I have 392 variables? It's possible to have a lot of variables. It's possible to have a lot of variables. And even if I don't have, even if I have 10 variables, so so I have enough letters for everything. It's still sometimes easier. It's just a little more organized sometimes. X1, X2, X3. So you see yeah, I don't know. It's just more, sometimes it's easier organized and sometimes you have that. Anyway, so what we want to do here, well, I would just let x. Now, generally speaking, pretty much as a rule, if you have, I don't know if this is an official rule. It works in every case, but definitely works in many cases. If you take the number of variables, the number of variables. But let's write this way. I'm going to write an equation which I just made up. V minus E equals T. Okay. Not T, I should write P. The number of variables minus the number of equations equals the number of parameters. So if I have one this is kind of always true after you've reduced the equations. I'll explain what that means. But it's certainly going to work here when you just walk through. So you have 3 variables and you have one equation. 3 minus 1 equals 2. 3 minus 1 equals 2. So that means there's going to be 2 parameters here. So instead of just having a parameter t, I'm going to have an s and a t. Okay, so I'm just going to let x2 equal s. And I'm going to let x3 equal t. Now I chose the letter s because that's typically the letter that's chosen for the second parameter. Problem, of course, is that my s's tend to look like 5s. So I'll try to be clear on that. X1 is going to equal, well, let's say it's going to be equal 2s minus 3t plus 1. So my solution set is going to be 2s minus 3t plus 1, comma, s, comma, t. Now, as I said, let me just skip through. As I said, I can't just randomly choose any x1, x2, x3, even though they're infinite solutions, but I can randomly choose an s and a t. So let's just randomly choose s equals 1 and t equals 2. So if that's the case, this is going to be 2 minus 6 plus 1. Yeah, 2 minus, right, which is negative 3. So it's going to be negative 3, comma 1, comma 2, as an example. And I'll write that example. And let's just plug that into the original equation. 13 times negative 3 minus 26 times 1 plus 39 times 2 should equal 13. So this is going to be negative 39 minus 26 plus 39 plus 39. Well, actually, I'm just going to write 30. I'm lazy. I'm going to write 39 plus 39. So the negative 39 and the positive 39 cancel. 39 minus 26, yes, is 13. So check. It worked. And oops, so you couldn't see what I was doing. Sorry about that. Try and get it all into one. Okay. Well, this is the original equation. I plugged it in, and how it all worked. Okay, everybody. Well, that concludes this video. I will make a whole bunch more and do a whole bunch more problems. It's been lovely, and we'll see you next time. Bye.